Do you ever wonder how to guarantee your machine learning models are both reliable and robust? Module 7 has the answer. Welcome to the world of cross-validation, a method that helps us ensure our models are not just memorizing the data, but actually learning from it. In essence, cross-validation is similar to a rigorous exam for your machine learning model. Just like students are tested on their understanding of a subject, not just their ability to memorize facts, our models too need to prove their understanding of the data. Imagine you're preparing for a big final exam. You wouldn't just study one chapter, right? You'd review all the material, making sure you understand each topic inside and out. Similarly, cross-validation ensures our models are prepared for any data they might encounter, not just the data they were trained on. But how does it do this? Well, cross-validation works by splitting the data into two sets, a training set and a test set. The model is trained on the training set, learning to predict outcomes based on the features in that data. Then the model is tested on the test set, data it hasn't seen before. This process helps us gauge how well our model has learned from the training data and how well it might perform on unseen data in the future. In a nutshell, cross-validation is like a dress rehearsal for your model before the big show. It's a chance to iron out any kinks and make sure your model is ready to perform at its best when it encounters new data. But wait, there's more. Cross-validation doesn't just help us evaluate our model's performance. It also helps us tune our model, tweaking parameters to get the best possible performance. This is crucial because a model that performs well on the training data but poorly on the test data is of little use in the real world. In the end, cross-validation is a powerful tool that helps us create machine learning models that are not only accurate, but also reliable and robust. So, if you're looking to create a model that can truly understand your data and make accurate predictions, cross-validation is the way to go. Cross-validation is like a thorough exam for your machine learning model, making sure it truly comprehends the data. Now let's dive into the world of k-fold cross-validation. Imagine you're a chef preparing a new dish. To ensure it's delicious, you wouldn't just taste a single bite, right? You'd sample different parts to get a comprehensive understanding of the overall flavor. This is the essence of k-fold cross-validation, a technique we use in machine learning to validate our models. In k-fold cross-validation, k refers to the number of groups we divide our data into. For instance, if we choose k as 10, we're partitioning our data into 10 equal parts, or folds. This way, we ensure our model gets a taste of the entire dataset and isn't biased towards any particular section. Once we have our folds, we then start the process of training and testing our model. We use 9 of the folds for training and reserve 1 fold for testing. The model learns from the majority of the data and then gets evaluated on the unseen test fold. But here's the twist. This isn't a one-time process. We repeat this procedure 10 times, each time with a different fold as the test set. By the end, each fold has had its turn as the test set, and the model has been trained and evaluated 10 times. This process gives us a range of performance scores, one from each iteration. We then average these scores to get a more reliable performance metric. It's like getting feedback from different judges at a cooking competition. The average score provides us with a more balanced view of our model's performance. Remember, the choice of k can have an impact. A smaller k might make the model less accurate, as it has less data to learn from. A larger k, on the other hand, might make the process more computationally intensive. It's a balancing act. So k-fold cross-validation is about breaking your dataset into k sections and then systematically testing your model's performance. It's a robust way to ensure your model is well cooked and ready to serve up accurate predictions. Now that we understand what k-fold cross-validation is, let's discuss its importance in model evaluation. Imagine you're a teacher and you've taught a student a concept. You'd want to test the student's understanding, right? But if you only use one test, you might get a skewed view of their ability. Maybe they were lucky, or perhaps they crammed for that specific test. That wouldn't give you a true measure of their understanding. This is where k-fold cross-validation comes into play in machine learning. K-fold cross-validation is like multiple tests or exams for our machine learning model. It gives us a better, more comprehensive assessment of the model's performance. By dividing our data into case sections or folds, we systematically test the model's performance using each section as a test set, while the rest serve as training data. This process helps us evaluate how well our model will perform when it encounters new, unseen data. This is a critical aspect of model reliability. After all, the real test of a model's worth is not how well it does on the data it was trained on, but how well it generalizes to new data. Let's take a real-world example. Suppose you've trained a model to predict house prices based on certain features like location, size, and number of rooms. You've done a great job, and it's performing well on your training data. But the ultimate test will be how accurately it can predict prices of houses it has never seen before. That's where k-fold cross-validation comes in. It provides a more robust measure of how your model is likely to perform in the real world. In essence, k-fold cross-validation is like a reality check for our models. It allows us to estimate the error rate we can expect when the model is applied to new data, and it gives us a chance to spot any potential problems, like overfitting, before they cause trouble. Remember, k-fold cross-validation is crucial in evaluating how our model will perform with new unseen data. We've covered a lot in this module, so let's summarize. We kicked things off by defining what cross-validation is, likening it to a rigorous exam that ensures your machine learning model truly comprehends the data. This technique is a cornerstone of reliable and robust model evaluation, and it's critical to understand if you're delving into the world of machine learning. Then we dove into the specifics of k-fold cross-validation, which involves splitting your dataset into k-sections or folds. This method allows us to test our model's performance on different parts of the data, providing a comprehensive overview of how well it's likely to generalize to unseen information. Throughout this module, we've emphasized the importance of cross-validation in assessing model reliability. It's a key piece of the puzzle in ensuring our models are capable, adaptable, and ready to take on real-world data. In Module 7, we've unveiled the art of cross-validation, specifically k-fold cross-validation. In Module 8, get ready to explore the world of hyperparameter tuning. Let's discuss when is the best moment to invest in cross-validation strategies. The optimal time to invest in cross-validation strategies is during the model development phase. This is the stage where you can ensure your model's robustness and reliability. It's the time when you have the opportunity to test, tweak, and validate your model against various sections of your data, identifying any potential weaknesses and working to resolve them before deployment. Investing early in cross-validation can save resources in the long run. Think about it: by reducing the risk of deploying an ineffective model, you're saving on potential costs associated with troubleshooting, reworking, or even replacing a model that didn't hit the mark. It's all about being proactive rather than reactive. To bring this concept to life, let's look at some real-world examples. Companies like Google and Amazon use cross-validation to fine-tune their recommendation algorithms. By constantly testing and validating their models, they're able to provide more accurate recommendations, leading to increased customer satisfaction and ultimately increased revenue. So to wrap it up, investing in cross-validation strategies early in the model development phase can lead to successful deployments, as seen with companies like Google and Amazon. Remember, in the world of machine learning, an ounce of prevention is worth a pound of cure.